Puppet classes help keep your code organized. This is a quick review of classes, parameters, and inheritance. Hopefully you're already a bit familiar with Puppet classes. A class in Puppet is a simple way of organizing code. If you've used classes in programming, the term can be a bit confusing. Puppet classes aren't that kind of class. They're really just a way of naming a block of code in order to include it elsewhere. Here's the basic form of what's called a class definition. Notice that it's a definition and not a declaration. Writing a class definition doesn't actually do anything. The class needs to be declared the same way as any resource declaration. Remember, classes are just a way of abstracting away a block of code, so this class declaration is roughly equivalent to copying and pasting the contents of the class definition, so that any resources that are in the class definition will be declared at that point. Don't worry if this terminology is a little confusing. It's actually pretty intuitive when you're writing the Puppet code. The syntax of the class definition is the keyword class, followed by what you'd like to name the class you're defining. There are some rules for how this relates to the file name, but we'll look at that later. After the name, there's a curly brace, and a class usually consists of several resource declarations. Finally, to close this class definition, use a curly brace. A class declaration can either look like a regular resource declaration, which allows you to set parameters if the class takes them, or you can just use the include keyword followed by the name of the class. In this example, I've added a few more things. First, look at the title of the class definition. There's a word profile, and then 2 colons, and then the word MOTD. This means that the MOTD class is under the scope of the profile module. In fact, you'll sometimes hear the : referred to as a scope character. It's possible to have multiple levels of this, so you could have profile, scope, system, scope, MOTD. When we get to modules, we'll look at how these class names are reflected in the directory structure and file names. After the class name, I've got some parentheses, and I've defined a parameter called message of type string. If you're familiar with Puppet but haven't used the newer versions, you might not recognize this syntax. Puppet now lets you easily enforce a data type for your parameters. Of course, this is optional, so you can leave that off. In this example, the parameter also comes with a default. This means that we can call the class without setting the message parameter, and we'll get the default message. After the parameter section, I've added an inherits, and this class is inheriting from profile scope params. Technically, you can inherit from just about any class here, but I strongly advise against it. Inheritance in Puppet is messy and can be seriously confusing, so the best and only use of it is to inherit a params class. If you need something like inheritance between classes, there are better ways. We'll talk about what a params class is in a second. The final difference between this class and the one on the last slide is that the content of the message of the day file is set using the message parameter. This is an example of how you might use a params class. A params class is where you set default parameters that aren't configurable within the module. Quite often this relates to the operating system the module supports. There's quite a bit of new syntax here, so bear with me. We'll cover it all in depth in later sections. First, take a look at the class name. Like our last class, this class is scoped under the profile module. On the next line, we've got 2 new concepts. There's a case statement, which selects between different sections based on the value of a variable. In this case, we're not using a variable. This OS family is actually called a fact in Puppet. Puppet has access to various facts about a system the code is applying on, because a tool called Factor collects that information about a node and relays it to the Puppet server. This example is the operating system family. We'll talk more about facts in a later section. In this example, we're setting a variable called admin user based on the operating system. On Windows machines, that's set to administrator, and on Red Hat-based machines, it will set the variable to root. So let's imagine this code is run on a Debian system. What do you think would happen? When Factor runs, it will record Debian as the OS family and send it back to the server. Then when the server compiles the Puppet code, it will try to match something in this case statement. Because we don't have an option for Debian, it will use the default. There's another new bit of syntax here. We're not setting our variable because our module doesn't support Debian. Instead, we want our code to throw an error at compile time, rather than leave the system in an inconsistent state. We do this with a function called fail. The syntax for functions is just the name of the function followed by a comma-separated list of parameters, enclosed by parentheses. In this case, we're calling fail with a string that will be our error message. Again, we'll cover functions deeply in a later section.